Exactly how much of your circular saw blade should stick out of the bottom of your workpiece for optimal cutting? I found answers varying from 1/8 of an inch to 1/4 of an inch to 1/2 of an inch to the depth of the gullet to as deep as it can possibly go. I decided enough was enough, so I decided to find the answer using as scientific a method as I possibly could. I took 5 different types and thicknesses of materials and cut them at various depths past the thickness of the material, and then examined the results to find out a definitive answer to today's burning question. I bought 4 of the most common blade tooth counts for circular saws from various brands, including 24 tooth, 40 tooth, 60 tooth, and the 140 tooth plywood blade. And then I started cutting. I figured it would only make sense to use the exact same saw for every single cut to keep things as consistent as possible. It didn't take long, however, before I learned that a brand new 24 tooth blade, which is going to be the roughest cut of all the blades, really makes nice cuts, even on tougher materials, so long as it's new and in good shape. Take a look at these results, for example. Keep in mind, this is the Harbor Freight $6 blade. Not exactly the finest of the fine blades. If this blade, at least when new, could make some pretty decent looking cuts at pretty much any depth, then that means the 40 tooth, the 60 tooth, and 140 tooth just didn't need to be tested. After seeing that, I decided to change up my methods. As it just so happens, last week I made a video about how even dull blades could render clean cuts with the help of 5 techniques, which I shared in that video. For part of that, I actually filed down the teeth of an already well-used blade to make them super dull and ideal for testing out my theories. So I put that very dull blade on my same test saw that I've been using for these tests and got to cutting again. Thankfully, I started to see some real-world results pretty quickly. Now, just a quick note about safety here. First, always leverage the circular saw's blade guard to minimize the amount of blade that's exposed. Now, it goes along with that the more of the blade that you expose by putting that blade down deeper, the more dangerous things are likely to be. In an ideal scenario, if you can have the very minimum amount sticking up past the wood, that's optimal. That's going to result in the fewest amount of accidents and the least severity for accidents that do happen. Of course, if you're going to put one way down, that blade all the way out like this, then make sure that you're being super careful because you're more likely to have accidents, and those accidents are likely to be more severe. So with that in mind, it's clear that the least amount of depth is optimal when it comes to safety. So keep that in mind, be as safe as possible, but what we're going to be looking at is what produces the cleanest cuts, assuming that you're using best practices and being as safe as you can be. I chose to cut every material at each of the 6 different depths. To account for the traditional suggested depths, plus the gullet depth of this blade, which was 5/16, plus the full depth of the blade for those that claim that sinking the blade as deep as possible results in the cleanest cuts. For those that are unfamiliar, the gullet theory, it's pretty simple. The gullet is this little cutout part right here in front of each blade, and traditionally that's used to collect any waste. As the cuts are being made, they can kind of gather in there, and then as the blade spins, it will eventually eject all of the gullet material or the waste material as soon as it's clear of the cutting material or the wood. According to this theory, if you set the blade depth to the full gullet height, that's going to be your optimal cut. The other theory that's a little different here is called the full depth theory. I don't know what it's called, but I'm calling it the full depth theory. That's basically that you want to put the blade as far down as it possibly can go, put that shoe or the plate of your circular saw all the way up, and get that full depth. The idea here is that you're changing the angle at which the teeth enter and exit the material that you're cutting, getting them closer to a 90-degree and, at least in theory, producing a cleaner cut. We'll be putting this one to the test. For my first set of cuts, I used a 3/4 inch solid pine board, which I think is pretty representative of softwoods, including 2x4s and other 2x material. And as you can see, the shallower the depth that I used, the cleaner the cut was. Now, one caveat that I need to explain for all of these cuts is that if we flip these over, you can see that there's a really nice clean cut pretty much on all of these. The one little thing I noticed on this one is that the 1/8 inch is probably the cleanest, and the full is maybe just as clean or really close to it. And then some of the ones in the middle are a little, and I'm talking a tiny bit more rough than those outside too. But here, the 1/8 inch actually came out cleanest, and then they basically got more and more rough as you went. So overall, for the solid wood, the softwood at least, and this is going cross grain, I'm gonna have to say that the 1/8 inch, the lower the depth, the better. Next up, I tried MDF, which is basically just a bunch of sawdust glued together and pressed. And because of the process by which it's made, there's really no grain, there's no grain direction, so you can't cross-cut. It's all the same no matter which direction you go. Now this is commonly used for trim, especially inside of homes, and I wanted to find out how this would cut, and it did kind of as I expected here. So over on your right, we have the 1/8 inch cut, varying all the way up through to the full blade depth. The full blade depth is by far the ugliest, and they just seem to get cleaner and cleaner as we get shallower and shallower. Similar results to what we saw with the pine. If you look at the back here, they all look really good. Next, I wanted to try some plywoods. Now with this thin 3/16 plywood, there's a very thin veneer on here, and this is the piece that I did with the Bauer 24 tooth blade that was brand new. They all look just about perfect with the exception of some blowout on the full depth blade. Now if we look at our longer cuts though, boy, we got a different story here. The 1/8 inch is again by far the cleanest, but still not all that clean with that dirty rough blade with those filed down teeth on it. So then we move to our 1/4 and it starts to get pretty ugly. The 5/16, which is the length or depth of the gullet, the 3/8 is actually okay, and then the 1/2 inch is looking really bad, and the full is looking like a nightmare. The full depth blade totally demolished this whole cut here. It looks bad through and through every which way. Once again, it's a pretty consistent gradation from 1/8 inch all the way up to full, as far as being clean all the way up to being super rough. If we flip this over on the back, we see some interesting things here. This one here is our 1/8 inch cut, and it's a little rough. It's actually one of the roughest ones we see here, with the exception of the full blade depth. Now, most of the ones in the middle look pretty good. I'm not sure what happened down here as far as some of this stuff maybe being cut or peeling off, but our 1/8 inch may have been a little bit too shallow for that one to get a clean cut, and it almost looks like it kind of tore some of that veneer rather than cutting it. Next is 3/4 inch plywood, and on the Bauer 24 tooth with the new blade, again, a little bit of interestingness going on here. We can see down here on the 1/8 inch, there's a little bit of tear out, and I'm not sure if that's from the 1/8 inch or the 1/4 inch, but a little bit of tear out in one part at least. Generally pretty clean throughout, and then we get some major ugliness happening over here on the full blade depth. So then we moved on to our long cuts on the plywood to give a better example, and this is with our dull blade. And if we take a look here, the full blade actually looks kind of decent. The 1/8 inch looks really good, and most of these look, I'd say, fairly consistent. I would say if I had to give it to one of these, the 1/8 inch would be the best cut again. But a lot of these are really pretty decent. They're not bad, including the full depth one. This is one of the best looking full depth cuts as far as materials are concerned that we've seen. Flipping it around to the back here, one thing that's pretty interesting is pretty much every cut looks identical with one exception, and that is the full depth cut. On the full depth cut, there is some definite tear out and there's some little fibers coming along, and it looks like it really did a bit of a number on those. Again, it's not terrible, it's okay at least, but the other ones all look better than that one. And lastly, we have OSB, or Oriented Strand Board. So this is 7/16 OSB. The thing that stands out with OSB is that none of these are great looking cuts. And again, that's because I had such a crappy blade on there with those dull teeth. But it made less of a difference with that blade on OSB than it did on any of the other materials. But I'm seeing tear out right through here on the 1/8 inch cut, as well as the 1/4 inch cut, the 5/16, the 3/8, the 1/2, and right down to the full. And honestly, there's not a big difference between any of these. There's not one that stands out as being a clear winner here. They all have some issues, they all have some tear out, and none of them are great looking cuts, at least with that dull blade that I used. So I don't think it makes as big a difference what depth you use when you're working with OSB. Now before I give my final results and my conclusions here, I want to share one important factor that I didn't talk about just yet, and that is that as you're entering the cut, the front of the blade is doing the work. It's spinning upwards and it's coming up through the top of the surface. Then as the back of the blade comes along, you might expect some other amount of tear out there. And that's one of the other things that I think is worth considering here. So it's not just about where it's making the initial cut, but also where that follow-up cut might make a difference. Having said all that, here are all of the pieces, and to me, there's a pretty clear winner here. 1/8 inch is the answer. So that's gonna be my go-to from here on out, 1/8 of an inch. It's safest, and from all the testing results I've got here, it produces the cleanest cut as well. If you want to take a look at 5 ways that you can get really clean cuts that are perfectly straight and actually do a great job at reducing any tear out regardless of what depth you're at, take a look at my video right here that shows these 5 clever methods. I'm Nils with Learn to DIY. Thanks for watching.